Thank you for the nice warm introduction by Alex. 50 years have passed since we are batchmates, and the warmth that we have between our batchmates, it's unbelievable. It's beyond all borders. The denominator is 5 years in hostel. That is the only medicine, nothing else. Today each of us are in different parts of the world, different economic status. So as he said, some of us are great achievers, but when we meet a batchmate or he asks that I should come, I have no hesitation. I knew that they would have, it's necessary. That's the kind of bond I think we should all develop, not based on any ulterior motives. That's just a general advice. So I wish to thank the Thrissur Management Association and the Engineers and Architects Association. You are a dangerous crowd for me, because all the traits that go into our construction field are here, and I'm glad I'm going to talk about a subject where I can't be challenged, but you can still ask questions. Okay. Thank you for also allowing some of my staff who have come from Alua to attend this talk. And so this talk is on a very hot subject. On the 28th of August, all of you, or rather the media forced you to watch the TV. There was a India-Pakistan match in the evening, but nobody talked about it on TV. The TPRs was only for the demolition coverage, and people forgot there was an India-Pakistan match. If you watched the TVs, there was no news about that. And we gladly looked at all channels, 100 cameras, all the broadcasting vans, all focused on the building. It's a rare event for us, a rare event for India, and a rare event for the world, because Noida Towers not only attracted engineers' attention, authorities and developers, media, and even school children, because they got holiday on that day. It was a Sunday morning, but still, even the previous day they had to vacate the houses. So this was a one, normally you can say one in a lifetime event for those who witnessed it live. This technology of implosion is not new. As Alex said, I did the first one in 1997. There was no media, there was a TV, and I've done more difficult jobs in the industrial scene. Within the industry, nobody sees it, only the industry people do it. So, but this captured the media attention, and that's why all of you are here to listen to what's behind this. And so I try to focus on what Alex said. As the topic says, it's an engineering perfection, or you can even say precision engineering. When I gave my first briefing on the day of the blast at 2 o'clock, before the blast we had a viewing gallery where all the VIPs, top consultants in India, top contractors in India, watching it from a glassed window apartment. So I compared this to a NASA or ISRO blast off. So I said, and it's true, all the precision required, the preparation required for the countdown for a blast of a rocket launch, the same has gone into this. And there's no second chance for us. But coincidentally, the next day, NASA put off their launch of the Elon Musk rocket next day, 29th. So when I mentioned it on 28th, I didn't know it was going to be postponed. Even they stopped the countdown of the rocket. Some of you may remember, whereas we could not have stopped the countdown with 100 cameras watching. So there is no second chance, especially in this kind of a media covered, whole nation watching, whole world is watching. So this is my second talk on this. The talk is in great demand. It's not that I only give a talk. There are some IITs are planning also talk. And, some large institutions, the Indian Concrete Institute has invited me. Dr. Anil Joseph here, he is also. So we are spreading the same words in different podiums and trying to give the message that India has reached that level, that we can answer the Supreme Court's order. So with this, so it will be 45 minutes given to me. It's 7:30, so 8:15 I will stop, hopefully, and we'll take the Q&A. Please, you can switch off your mobiles or put it on silent, and you don't have to stop me when I'm on the slides. You can stop. We can go back to the slides if there's a question. Because of my experience in bringing demolition technologies in India, I've also brought in the recycling technologies and recycling advice to the Government of India on the recycling codes. We have changed the ISA 383. Those of you civil engineers here on aggregates, we are now allowing recycled aggregates in virgin concrete. This was not there, so a lot of work has done. The Government of India rules have changed, the IS code has changed, and to permit the use of recycled material. It was not so earlier, but we have made a small beginning, allowing people to use, and consultants must now boldly go and use it. That is the problem. We are not using this, who's to bell the cat. There's always somebody is asking, why should I spend on, why should I use recycled material? It's the psyche. So we are psychologically affected not to use recycled material. Unless, so this is a beginning we have done on recycling. So quick recap, quick introduction of what I am doing here. Demolition is not my bread and butter, it's my passion. So I run a business of these brands here. So we have 4 companies. ACT is my founding company 35 years ago. PACT is the company exclusively for Kerala. I have some of my managers here, and Pack Power is another company, and Bomacrete is a factory making decorative concrete products. India is a great opportunity for so many things, and only that much I can do. So some of these are big brands which we represent. All these are, some of you may recognize these brands of construction equipment. These are construction equipment, so we are selling and servicing equipment. In Kerala, we have about 1,500 customers. Correct, Girish?
Yes, sir.
Yeah. So we have 10 offices. So that's my bread and butter. And we are in all these served segments across the 2 states where we concentrate our business. And we have 10 branches in Tamil Nadu and Kerala. But these have nothing to do with demolition. We sell equipment for demolition contractors. Now, all of you know there was 2 towers that were demolished. So my outline of this lecture is fact file. Those of you who don't know the real facts, there is a fact file saying what really is a fact file of the case. What led to the demolition? Again, you all know it's a Supreme Court order. So what led to the demolition of that, and what led to the Supreme Court order? Why this method of implosion was chosen? Again, so many methods we could have used. What is the engineering behind it? I'll stress a little bit more on this today. What is the engineering? It is not by chance that it fell down perfectly. And identification of risks and mitigating the risks. This is a very big exercise we went through. And what is called the blast design. None of the structural engineers will know how to do this. So blast design is select structural design. We did do a blast design, and then we did a test blast on the actual structure. You may call it risky, but that's the only way we can prove that the blast design will work. I'll explain more on that. And prepare the structure for the implosion. As no structure can be just imploded like that. We need to prepare the structure. A lot of engineering and analysis goes into that. And on the D-Day, 28th of August, what are the activities? A lot of coordinated activities between government departments, so many government departments, the residents, and what were their main activities. And we took this opportunity to collect enormous data. The data collected are still being processed. I'm going to show you some data. So you are privy to this, but we are still processing the data because it's a great learning for all of us. Data collection and during and after the blast. And I have a slide which shows my critical review of the performance of the blast. I've given myself marks in certain areas, and I've also given less than 100% in a few areas. We have to learn from our failures. Was it a failure to the common man? No. But from the engineering point of view, I'll show you how it could have been better. And what is happening now is another 3 months of secondary demolition and debris handling is happening right now as we speak. So now it's about a month, so we'll take another 2 more months, go to the bottommost second basement. And recycling and debris cleanup. A huge amount, 100,000 tons of debris coming out. But we don't have a plant to handle the recycling in Noida. We have in Delhi, but it's too far off. So it shows the gap that if a technology is brought in, we must have recycling plants so people can use it. So that's why you find everybody dumping on the streets, because there is no recycling plant in Thrissur. All of you should get together, and there are many cities I am helping in setting up the recycling plants. And finally, what is the lessons learned? It's a contract to demolish the building, but there are lessons to learn as an engineer, as a general public, and definitely from the management point of view, how it was managed to such precision. I don't know if you can read, it's a short, I don't think you can read from the last rows. So this is the story behind what really happened before and what led to the demolition. So Noida, but let me talk about, there are 2 towers, you can read, try to read here. There are 2 towers, Apex and Siam. These 2 towers were given permission to build 40 stories. Mind you, I'm saying they got permission to build from the Noida authorities. The builder or the developer, Supertech, went as per the sanction. Now this residence here of also the same campus of Supertech went to court. These are 15-story building. They went to court saying these 2 towers were not shown in our original sale when they marketed the flats to us. They are all retired government officials. And this is cutting off our sunlight, our clean air, and we don't have anything else to do. We were going to look at some structure and we didn't pay for that. And this is the sole reason they went to court. Against the builder from whom they bought this, and that builder was building this. But this builder already has sanction. So what prevents him to build? So he was building, he reached up to 33 floors here, and this building also reached up to 28 floors or something. And Allahabad High Court gave a stay order 2009. They went to court in 2009, somewhere here. The height of the structure is about 105 meters, 103 meters. And this is 97 meters. Mind you, there was construction, there was a tower crane and the passenger lifts. High Court gave an order to stop. The residents, see the Resident Welfare Association, was fighting against the giants, which is the Noida authority and the builder. And then they lost the case in Allahabad High Court. They went to Supreme Court. By the time few of these retired government officials died out of giving up on the system. All their life saving. They are all military officers, government officials. So they were really fed up that they are not going to get their pound of flesh. This was the attitude. They went to Supreme Court. And you see, the fight started 2006 and the order was passed in 2021, 22 actually, February. So this fight, during this long fight, work was stopped because there was a case. So the work was stopped and the builder was trying his best to get the court settled. But the Resident Welfare Association are saying, no way we're going to give up. You know, they don't have so much money, they're retired people. How do they fight a case in Supreme Court? So 30 hearings they went, they attended. If you hear their story, you'll cry. They went thinking they will lose. They couldn't hire the best of the lawyers. The other guys, they had the best of the lawyers. But Supreme Court said, and then the builders, he said, okay, you are saying this is only 9 meters. Between this building and this building was 9 meters. Such a tall building, fire engines cannot go. Of course, they fought for sunlight and clean air was not there. And this was shown as a green area in the original plan. So their fight was legitimate. And if you look at the other angle, fire engines cannot go around. There is a gas pipeline going in for the Gas Authority of India. And as a builders, their own way, they try to somehow say that we will cut down the building height and we will chop off the building vertically. I mean, they will try all options in order to save the building and the money. And in the meanwhile, they have taken money from new owners of these two buildings. And Supreme Court gave a ruling, nothing doing. You've done, and of course, colluding with the Noida Authority. He had sanctions. He had building permits. So from his point of view, I have a permit, I will build. But the way the permits were given was in question. But Supreme Court, after analyzing all this, they said, we are not going to entertain any sort of via media. We uphold the decision of Allahabad High Court. And then they turned to Noida and said, you better get it done in 4 months. You better get the demolition done in 4 months. That's when I came into the picture. So that's the fact files. And it's actually it's a very sad case till that stage when till the stage order was passed. Now coming to the engineering aspects and the risks aspects, these two buildings are super tall, they're more than 100 meters. It's among the 13 tallest buildings imploded in the world. And so the distances between this and this was only 9 meters. And there was a main highway going on this side with electrical lines. There was, from between this building and this building, there was an ATS, another building about 16 meters away. There was an underground gas pipeline running here, 3 meters by Gas Authority of India, pressurized gas, which they would not shut off. So it was it's a big challenge that all possible failures is possible if you don't do it with high precision. So this is the story of how the plan got, whatever story I told you is 2012, 2014, and it was decided that that building has to go. So Supreme Court said nothing doing, will not entertain. Lot of narratives in the media saying we can put it to use for economic housing, we can fine the builder, you put a big fine. Lot of narratives. Even my own friend said, Mohan, don't get involved in this. Why waste of national asset? But this is an engineering job to be done. I have no role to play in giving my personal opinion. Somebody has to do it, an engineer has to do it. And it's a Supreme Court order. None of us, I believe, has a right to question Supreme Court. Their decision is final and they have taken good amount of advice from everybody. So what they said is, in the order, so on January 17th, the top court approved the proposition for the demolition agency. We proposed, and here they said very clearly that if the Noida authorities don't have the expertise in India, or don't have the expertise, they could take the help of CBRI, Central Building Research Institute in Roorkee, a wing of the CSIR. They can take the help, and if they don't have that expertise, they can go to anywhere else. This was in the Supreme Court order. So CBRI brought me in and said, CBRI has no experience in blasting. So CBRI director and said, Mohan, please come on board because we don't know anything about blasting. And Supreme Court just simply mentioned their name without even asking whether they are the expertise. They are material experts and research, and they are not in practical demolition. So my involvement was because CBRI brought in, and Noida authorities called me, and there was selection of the suitable agencies. And that from that stage onwards, my role was sort of a guardian of the technology to make sure the precision work happens at every stage, even during the during preparation of the structure. And Edifice Engineering got the job from Mumbai, and they have never done this before. They have done one job in Maradu. Maradu also, my role was there, and I got involved in this job from last December onwards. As you can see, Supreme Court, Edifice, CBRI, and Jet Demolition was their partner from South Africa, who is an expert in explosive demolition. Now, I'm going towards why we chose this method. Obviously, in any contract we choose, what are the methods available, what is the cost, time and risk implications. Even in your own management, you will do this. So we did this quickly, and the slide shows this is one type of demolition using robots and high-reach excavators, and the risk is low, cost is medium, but time. Supreme Court said 4 months. Just like they said 90 days for Maradu, 4 months. We knew it was not possible, but we could go after some time and see whether they will give us extension. That's really what happened. There's another method. I'm not getting into the methods. It's a diamond cutting with tower cranes and high-reach excavators. So that's again very high cost, and will take at least a year. The last one is implosion of the superstructure and disposal of debris. So I estimated 5 months, though the Supreme Court said 4 months. I mean, they have not done the analysis, they just said 4 months. So it's a very lowest cost, but a very high risk handling explosives with all those constraints of nearby buildings. But we took the challenge, and this was approved and proposed. I'll skip this because we are little more details on each method. Everything was, I can say one thing, total spectrum of methods was analyzed in detail, not just this table. For every method available in India or not available in India, we did the risk analysis, the mitigation methods, and the safety document. Then we presented to Noida authorities, because they are the final decision maker. Because in future, if something goes wrong, then the question will come, have you looked at other methods? So this picture is Maradu, that was 2020, all of you must have seen this. So it was successful, and the method was well known because of that job. We chose the implosion method. Now coming to implosion as a method. Implosion is a word coined by an American company. Explosion is everything going on. Implosion is coming within. This was coined by the American family. Now, what are the plus points we had to choose this method? Because such a large building, tallest building, such a heavy building, never been done before in India. Edifice, the chosen contractor in Jet Demolition, have an impeccable record of 0 failures. Here you don't have a second chance. If something goes wrong, people get killed, collateral damage, it will have huge repercussions. Successful demolition of the same combination of these two companies in Maradu was a good reference. And the Supertech structure which I talked about, the twin towers, requires weight. For us, we cannot do this for less than 6 stories because of the weight. We need the weight to pull it down, and we need gravity. We can't do it on the moon. We need the gravitational pull so we can direct it, we can direct the force in the way we want. So this is a very heavy structure and ideally suited. So Supreme Court simulated the blast date within 4 months, and no other method we could think of can be done in 4 months. So shortest duration. Now, if you look at the design capabilities at every stage, whether we had the knowledge, whether we had the capability, whether we can perform the design, have it checked, yes, we had most of it. The rest we said we'll go along and do it ourselves. And this is the fastest, safest and most economical method in this context. Confidence in the method. So I was for one vouching this, that I'm very confident this building can be brought down safely. Others had no experience, the Noida authorities had no experience, they were apprehensive about it. There's so many other people there, fire, police department, fire administration, so many people, they've seen only on YouTube. But confidence on the method for the people, key people involved mattered. Now environmental factors like dust, noise, vibrations can be monitored and mitigated to a certain level because they're prime residential zone. So we have to do all that is in our powers to mitigate this temporary environmental factors. And you know, environmental people will raise the flag for anything like this. So we have to go through pollution control board, air quality index and all those things. And risks such as flying debris and dust can be controlled. So we have spent a lot of time and money in working out these two factors of flying debris. When you say flying debris, an aggregate in concrete, those of you who are concrete engineers, it has aggregates. The aggregates fly as missiles. At 100 kilometers per hour it will fly. If it hits a human, it will go through the human. And you obviously will die. There are many accidents happened outside India. So we have to make sure that this is prevented. In India, we are all curious people. When we say don't go beyond this line, somebody will try to sneak in and take on video for his family. This is part of our Indian culture. We want to break the law, sneak in, and we expected this to happen, and it happened, and we caught some people. So they somehow, come and camp overnight, hide themselves in vacated building, and then suddenly they'll show up and want to take a video, and that fellow gets hit, finished. This is expected in India. And you say don't do it, they will waste to do it, and they will always do it. So we have to be very careful. There is no human curiosity, especially the media guys. They place some remote cameras without telling us. So many things happen that they want to be the first to capture and show the world. But that could work reverse. If they get hurt, it'll come back to us. So we have to make sure that there's nobody around, and all these precautions have to be, and the flying debris and dust can be controlled. Now this is a little bit more technical now. I want to say that there is a blast design. So the blast design is to make sure where the explosives will be placed, which column, what quantity and what sequence. This is a very important component of the building coming down in a manner we want. So you can see this one typical tower. We have showed one of the towers. So we have the black lines are the primary blast towers, floors. These dark black lines are the primary blast floors, which means selected columns in these floors, selected columns in these floors are charged for blasting. Not all. These are secondary blast floors where again secondary columns and shear walls are blasted. And they are also blasted in a sequence, which I'll show you in the next slide. We also use a formula for the powder factor. Suppose you have a column 1 meter by 1 meter with reinforcement. There is a certain amount of energy required to make the carrying capacity of the column in compression zero instantaneously. So that keeping the rods in place, but shattering the concrete instantaneously. So this is the guesswork and experience, and from the confinement of the concrete and the amount of reinforcement, we have to decide by experience. And this was designed for all the floors, selected about, you can say 60% of the selected floor, the columns and lift shear walls were removed, and pre-blasting we had to remove a lot of supports. Nearly 20% of the supports were chipped off because it will arrest the fall. I'm not going in depth in it. So this is we have formulas to use, and they theoretically select the columns through a software program we had, and complete. So the building was about 12-13 stories fully finished. The partition walls, the tiles, the kitchens, the bathrooms, they are all fully finished, and they are slowly finishing and going up. So we had to come and strip everything, and it had two basements. But in the sold out floors, we had to remove the extra weight, which is the granulithic portion, the marble, the toilets, the kitchens, all this, and the end partition walls, parapet walls, non-structural walls, everything had to be removed. It took us more than a month and about 100 loads of truckloads to be removed, sajjas, balconies, everything, whatever which will come to stop the fall, we had to remove. Identify, mark and spray paint so that the workers don't remove the wrong things. So the blast, now in the blast design, a critical portion is the delay in milliseconds. I will have another slide to show you. What you hear or what you see is just one blast, but it's a series of blasts followed by delay timings. These delays are meant to be to make the building move. The principle is, if you stand here like this and then you break your knee, you will move the same. Same principle we use. It's the same principle we use to move the building. That the initial move the building so that the CG of the building moves away and natural gravity takes over. And we calculate the 9 seconds was calculated again and again. And all the fall stoppers like partition walls, I said, everything, an extra weight, everything was removed. Even after that, we had something like 100,000 tons of concrete and steel standing on top. So this is an interesting portion, the blast design. So you can see I've given you one plan of one floor showing how we are pulling the building in this direction. So this is the zero. This is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds in the middle floor. In the top floor, it will be 9th second will be at the top. Then we have the landing zone. So all this put together is calculated, and the dark lines here are the columns that are being charged. So it just gives a summary of how we are blasting from here to here, from in each floor in one direction where we want to pull it like this, and in the upper floors it goes to the right at the top. It's complicated to understand, but we had drawings for every floor showing the delays And this is the 9-meter building which had to be protected. We had containers, empty containers, seagoing containers here stacked up and also draped. And this shows the blasting floors and the secondary, primary and the secondary floors. This here shows the expected debris plan. You see, what was planned was the entire debris must come within the boundary of the property. And this here, I know you can't read, this is the gale pipeline. Now if anything had ruptured in the gas pipeline, it would have been a fire. And we had to go through several rounds of discussions with them for them to give us an NOC. And they would not stop it, but they were concerned about the vibrations or a leak from the gas pipeline. It's a main line, it's a 450 mm diameter pressurized gas line going 3 meters away and 6 meters from the building. And this was the way we protected it. All along we had a steel plate on top of the berm, on top of the pipeline is here, and we had earth mounts around on top of this to soften the blow if it falls. So every single risk was very thoroughly analyzed. Time is not enough to go through everything. And then we have to weaken the structure. We don't want anything to stop the fall when gravity takes over. So here you see that which are the columns and which are the shear walls that have to be broken and to what extent. So the red one shows which are the ones to be broken. Suppose there is a shear wall of 4-5 meters, how much we remove. And after we do that, there could be an earthquake in Noida, there could be a high wind, and the building is so weak. If such a thing happens, almost 300 people work every day in the building, at some parts, in some floor. If the building collapses because we have weakened it, that's a huge risk. A full structural analysis was done on the weakened structure. So after the breakouts, when I say breakouts, demolition partially of the columns, and I will show you pictures. So after the breakout, we had to ensure by structural calculation to show that the building is safe. But we used lower factor of safety because there were only few months. But this was also had to be considered. If you weaken the structure so much and there is a slight wind, and there was an institute in India who said winds will bring it down. We had anemometers at the top level. We had wind speeds about 50 meters per second. That was high wind. So we were concerned whether the high wind will shake the building after it is weakened. And if there is an earthquake, God forbid, the whole building will come down and people will die. So you can imagine the amount of engineering we have to imagine and do to protect ourselves, to protect our name, and also to, it may not happen, it's like taking insurance. You wish it never happened, you wish your car will never get banned, but you still pay for insurance. One of the most critical things is the ground vibration. Everybody is bothered about ground vibration because the nearby structures were weak, and we are dealing with government authority, we are dealing with CBRI, we are dealing with Gas Authority of India. So we have to go back to the literature, and in IS code, there is an IS code number here which allowed and the formula to be used for calculating or predicting the ground vibration based on the soil mechanics. And I'll show you what was achieved. So this is all permissible peak particle velocity, PPV we call it, in millimeters per second, allowed for normal structures, industrial structures, sensitive structures. We went to all this, and then we fixed and we predicted that it will be the maximum will be around 27 And it's a known fact among structural engineers that up to 25 millimeters per second or 1 inch per second peak particle velocity, nothing will happen to a good structure. But we had some very bad structure which had to be crack mapped and retrofitted at cost about 25 lakhs before the blast, because we knew that structure will not withstand even this vibration. So the amount of engineering that has gone, I am just showing sample slides. You can imagine each one is a report. And the prediction was done, and then we refer to all these formulas to find out the peak particle velocity. And this is the Indian code, mechanical vibration and shock, to buildings, guidelines for measurement. And we brought in Dr. Anil Joseph of Geostructurals, Cochin, and he brought in IIT Madras to monitor extensively ground vibrations and protecting the nearby structures and retrofitting them if required was given to them. They are good at it. IIT professors were involved in measuring. So ground vibration prediction and making, and it also depends on the fall. If you make the whole thing fall down with a high velocity, the vibrations will be high. So we have to make sure the blast sequence is low and also the fall is curtailed by the steel rods. The rods rods will bend and bring it down slowly. It will not like fall as a one complete thud. And these are the points that we had put. Now, how do we measure this? These are all very theoretical. You can go by numbers, some reports, and so we decided to have a test blast based on the charge per cubic meter column, based on the vibration levels. So we did test blast in 5 locations. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 was in the basement, in B1, basement 1, and this was in the 13th floor. And these were on the pipeline and some distances away from the building. We did an actual test blast. We charged the columns and blasted it. This was in April, sometime in April. Why we did it? Because we want to be sure whatever we have designed theoretically will work. If the blast charge is less, building will not fall down. It will just stand there and we will feel. It will be a ridiculous thing for us to, nothing has happened. There was a blast. So we did a test blast and we had a good learning. I'm going to share that with you. This shows the closeness of the buildings between this, the gas pipeline, and the 9-meter structure, road, very tight site. Now this was the test blast. The idea is to blast the columns in such a way that the concrete is shattered, and from there we will decide whether the blast charge is too much or the blast charge is too less, and whether correlated to the vibrations being measured. So all this was a learning for us. So test blast and learning was, the test blast is carried out on select columns as I showed you. Explosive quantity was different for each column. Purposely we changed the density, the powder factor. And then the blast penetration, we checked the blast penetration after that. And then we altered the design. We found the building was too strong. And obviously, those of you structural engineers here, about 5 to 6 kilos of steel per square foot was used. Obviously, the developer, when he got a sanction for 15 floors, he knew he will go to 40. So he had already put enough reinforcement and the quality of concrete, very high strength concrete at ground level. Even though the sanction was only, and question is how did he put so many piles when he did the piling. So all this was something that we can debate, but the building was super strong, more than what we expected. So we had to change the blast design. We had to increase the amount of charge per column, and we also had to increase the amount of protections we had. the design was altered, amount of charge per hole should be adjusted enough to shatter the concrete but not to cut the steel. Stirrups, sometimes we cut the stirrups in critical columns so that they don't have the hoop stress effect is removed. So the amount of protection and the border factors were increased. Ground response was studied and the final blast design changed to 9 seconds of fall. Earlier it was 7 seconds and we decided to have a 9-second fall, more columns to be blasted, more charge to be added. It really doesn't matter 7 seconds or 9 seconds, it really doesn't matter, but for us it matters. And based on the test blast we had more confidence, the residents were more confident, they were all imagining something, when there is a blast, something will go wrong with the building and their building. More confidence in the system. And the public itself, the police, the public, the fire department, they were all in place like a normal blast drill. So they were all confident, okay, this is what is going to happen. It was a dry run also for them. And just to give you some numbers, before the blast and after the blast, the number of holes increased from some 8,000 to 9,000 holes. See, the blasting is, the explosives are put in holes, diamond coated holes, and the number of holes increased because we had to hit, number of columns increased. The total drill meters from 13 kilometers to about 17 kilometers, total length of drilling inside. So you can see here all the other quantities and the number of wrapping for the geotextile and chain link fence. I will show you pictures. Doubled because the energy we are putting is so much. The joules per cubic meter was so much that we was afraid that it will shatter whatever protection we go and fly. The test blast was a good chance for us to learn how the building responded to the explosives. Now risk mitigation and risk identification and mitigation, because it has now been done before, identifying the risk very carefully, documenting it, debating it. All this was happening while the building is being prepared. And then, have an exclusion zone of 250 meters so that nobody is there on the D-Day, they removed. So this is a sample of so many exhaustive risk analysis done, typical sheets. So these are all the exercises we have to do before we went into it. And to a certain extent mitigate the risk. We had so many agencies, including air traffic also. ATC had to stop for 1 hour. And the Army and the Air Force and Navy all had to stop. Not Navy, Air Force had to stop. And we had our drones, so we had permission for. So you can imagine so many nitty-gritty things have to be discussed, finalized, and dealing with the government, making them understand, come to the meetings. So I just showed you samples of the disaster management. Now things can go wrong. What if it goes wrong? So we had doctors, 4 hospitals in standby, we had doctors in attendance, ambulances, fire engines, what not, in the disaster mitigation plan. Here I must say the authorities cooperated because for them it is actually, the Supreme Court order was for the authorities. So they had to make sure nothing went wrong. So these are all things happen, before the D-Day. We will never get to hear this otherwise. Now some of the mitigation methods, every single column that was blasted had this 2 layers of geotextiles, 6 layers of geotextiles, 6 layers of chain link fence to hold the concrete from flying, to hold the debris. We had earth berms, as I told you, on top of the gas pipeline. We had trenches to cut off the shock waves on the ground. To soften the fall near the roadside, we had these tires. And about 25 fire engines were in place all around. And noise, dust, and ground vibration and air overpressure. Air overpressure means it will go and break a glass. So to prevent that, we need a screen, dust screens. So air overpressure was calculated Still, we thought some glasses will break in the nearby buildings. Flying debris, I told you about these missiles from the blast floors to be curtailed, collateral damage to be minimized. This was something that we can be faced with a load of litigation if there is a collateral damage. So we took an insurance for 100 crores. Third party insurance for collateral damage was 100 crores. And I think we used up some 3 lakhs or something, small damage of glass and compound wall, hardly anything. All emergency services, no fly zone declared for 1 hour, which is from the all air traffic. 5,000 residents were vacated. At 6 a.m. it started on that day, and they were asked to return at 6 p.m. in the 12 hours they all had to leave. And we had to go door by door, house by house to make sure somebody is not hiding under their bed, because they want to see it firsthand from their window. So all this had to be done. And 250 meters of exclusion zone, which means nobody around. We had police with walkie-talkies. So we had all these geotextile drapes, standby emergency teams. Before this was done 24 hours before the blast date. Flying debris, and you can see all the buildings nearby was shrouded with geotextile, all of them. And every column had chain link fence, 6 layers. We had dust cannons mobilized around the streets nearby, like this, spraying dust. And all possible mitigation methods, all possible knowledgeable risks were addressed. A nearby building, one building we found to be unsafe. Dr. Anil Joseph found that to be unsafe. We did a full analysis of these nearby buildings to make sure that they will withstand the vibrations. And in terms of some numbers, to prepare this is how the structure was marked for this area to be removed. So this was done in so many, this is a lift well, so much areas, how much ever to be removed, and 17,000 meters of diamond core drilling, as you can see, host of diamond core drills used, long, almost 3 meters long, chipping to weaken. So by way of numbers, we had 17,000 meters of drilling, 34 mm dia, 20% of the shear walls were knocked down, 45,000 man days in 6 months. So the job was not 4 months, but 6 months. So at the end of 4 months, again Supreme Court called, and they went for extension of time. And it was online. I appeared on Supreme Court, and my opinion was taken by Supreme Court. And I said they must be given that time because the quantities have increased. We could not predict this. We did a test blast, and they also understood that we could not have known in February. So they gave us that extra time, and they fixed the date. That was, it's a 2-bench hearing, and as a civil engineer, they could hear us. They could hear me give an opinion, and the decision was taken based on I was one of the one who, there were others also who gave opinion. Man days, 45,000 man days, and total chain link fencing and geotextile is 3 lakhs square meters. Huge quantity. Everything had to be done, brought inside, hoisted, put in place. Not a single accident inside in 45,000 man days. This is a record because they didn't work in the night, but at heights without edge protection. We have removed all the edge. Everyone had safety gear. All safety was followed. Equipment. Huge amount of equipments were used just to show you the magnitude of the job. Excavators, breakers, skid steer loaders, hoist, platforms, diamond core drills, and 45,000 liters of diesel for this equipment. Generators, 6 generator sets, and we used about 3,700 kilos of explosives. As against 2,500 that was planned before the test blast. Explosives. This is subject none of you may know about it. What is an explosive? So these explosives are locally made. They are called emulsion explosives. These are the explosives. Then you have all these cords, and this is how it looks finally. Finally charged whole with the connecting cords. It took 18 days to charge the building completely, all the floors. Imagine, no lights, no lift. 33 floors, walk up and down every day, 18 days. A team of 20 people, all authorized to handle explosives as per Indian Explosive Act. There was a person from PESO sitting there to make sure it is handled by licensed explosive handlers. Because we have them in the mines, so we brought them. But imagine walking every day up 32 floors, 33 floors for 18 days. Nobody else was there, nobody was allowed inside. So this is the bunch of 100% Indian. So we didn't want a foreign company to supply. So it was done by an Indian company. And we used a system which, even if there is a misfire, nothing will go wrong. This is important. That if there could be misfire, and if there is a misfire, can something happen? If there is a lightning, can it trigger? So we were watching the weather also, Damini app, which some of you may know. Damini app gives the lightning in the vicinity on a live basis. So this system was fail-safe. Nothing can go wrong if there is some incident like that. Engineering studies, an enormous amount of modeling and engineering studies done to check whether the buildings will withstand the other buildings, not this building. The other surrounding buildings can withstand the dynamic forces of vibration. So I'll just show you just one single one building and how the model analysis is done, and the acceleration time history for the design parameters of the blast force, particle velocity. We modeled it for 36 millimeters, even though we expected only 25. But in the model studies, then we went to retrofit the building. About 25 lakhs was retrofitted with one building. All other buildings which are old, not old, about 15-20 years old, cracks were marked so that there is no case later. They cannot come and say because of the blast this crack has come. It was mapped and also telltales were put in those cracks. So we did a detailed survey of before and after the blast of all these buildings. On the blast day, 28th of August, all of you were watching TV while we were doing all this. Evacuation of the residents, 7 a.m. to 7 p.m. Evacuation of the exclusion zones completely. Standby, I think I covered all this. VIPs in a viewing gallery. The VIPs were invited contractors, like large contractors in India were there, consultants were there, association members were there, BIS code, people who make the code were there, Engineers India was there. So we could invite most of these people to watch this spectacle. And I gave a overall review of what to expect. I also said, it can be a failure, you expect that also, that it could fail. Then you'll all say, oh, it failed. Yeah, it can fail. I have to give a review and prepare their mind that it may not be a success. We had drones in the air, and 3 times the walk around happened in the day because we are afraid of pigeons, birds coming and disturbing the wires. We had hooter horns to chase them away. Dogs were caught one day before, all around, dogs were caught. And 3 times the building walk around happened to make sure nobody has entered on that day. And the last mile connectivity to the blasting zone happened just 1 hour before. Drones were in the air, ground vibration, air quality instrumentation were ready by IIT Madras and Dr. Anil Joseph. Everything, it was a huge combined effort. And I said, I will do the puja, because whatever engineering you do, sudden maybe need the help of God Almighty. So here you see we did the puja away from the cameras, and Joe Berkman, who was the managing director of jet demolition. I did Sankalpam for him. He was so happy. He finally told me, your puja actually helped us. So he was somebody outside from India, foreigner, believing that even the expert needs that help. And this is on the D-Day. This is the team from Engineers India. And Joe took the VIPs inside and showed them how the building was prepared. They were taken inside the building for a few minutes. It was like a major gala event. And all of you have seen the video. I'll skip the video. You must have seen it 100 times. You can go to the YouTube and see. So these are the borrowed videos. And data collection is again instrumentation. A lot of instrumentation was done. And geophones, accelerometers. Then we had the CBRI put some black boxes. Indian Army came and put some thermal sensors. We had drone sensors. And we had these geophones on the ground. This is Professor Joseph, Anil Joseph, and Professor Bhuminathan. So it was academically a great chance for them to gather data and learn. Today morning I called and asked, have you processed? They're still under process. SINFAR was involved, Center for Mining from Government of India. I'll skip, I will not explain too much of this. So, and the analysis of the blast performance, from the data we have, the peak particle velocity which we expected did not cross 7. Somewhere here I also can't read, it's not focused. What we expected, the upper limit was 25, it did cross 7. So it's a grand success for us. And the GAIL pipeline, within 1 hour, they gave us a clearance that there is no leakage and the pressure didn't drop. So they gave us a clearance and nobody got hurt. So the blast analysis of blast performance was air quality index, though you saw the huge dust come in, within 30 minutes the dust was not there. I was there on the watchtower. 30 minutes later also pictures I had. AQI published by the Pollution Control Board cleared it on that evening itself. So 3,700 kg of explosives was a good blast design. There was not a single misfire which we could verify to a certain level, but there was no misfire. And 9 seconds achieved the full collapse. Suppose it did not achieve the full collapse, halfway it could have stopped. Because the blasting is over, building has not fallen down, it could have stopped halfway. So 9 seconds was a good prediction. And I'm not going through all these numbers, and these are all the actual recorded peak particle velocities. The first peak is the blast, the second peak is the with the falling of the building on the touchdown. Now, for me, it's not 100% success. That's why I said, if I analyze it critically, here you see a slide where I have critically analyzed it here, and I have given marks to myself. Because this cannot be shown to non-engineers. We all hugged each other and said fantastic. But if you see, vibrations, fine, noise, fine, dust, fine, debris footprint. So if you see the debris footprint, these are drone pictures taken immediately after that. So the debris has gone beyond the level, it should not have crossed this level. So debris footprint, question mark. And collateral damage, there was a collateral damage of compound wall about 9 meters, it should not have hit that, and 3 top floors did not break up. You can see very clearly, these are the 3 top floors from both the buildings, did not break up. So as far as I am concerned, I give myself only 95% overall marks. But there no damage to the 9 meter away here, this building, absolutely no damage. Building was pulled this way. GAIL pipeline was functioning. No damage to this building. No damage to ATS building, but just near miss. This is a near miss. This should not have happened. It's a near, if this had rolled over, in the momentum, if it had rolled over, it would have hit the building. None of you would have noticed on the TV Here's the critical analysis of the drone. So top 3 floors toppled without breaking. It's a near miss. And it fell on the gas pipe. So we had the steel plate, and we also had the earth berms. They helped us. It fell on the pipeline. As I told you, pipeline is running like this. Nobody will talk about it. It's 100% marks for everybody. But if I evaluate, 95%. So there is room for improvement. Right now, this is what is happening, which is recycling of this debris and about 4,000 tons of steel going for recycling, and a lot of dust created, and this is the usual process. This happened in Maradu also. 4,000 tons of steel when going to melting scrap, and a certain amount of debris going to recycling yard in Noida, but that's not enough. So it's a 3 to 4 month activity still going on. 1 month is over, and the recycling has to be borne by the cost is borne by the contractor. Lessons learned. This is the last slide. 3 recent demolitions in India. The first one was in Chennai, Mugalivakkam. Second one was Maradu. Third one is Supertech. These 3 demolitions have sent a message to the public, from the public to the developers. So these 3 demolitions of illegal structures have reinstalled confidence in the Indian legal system. This will go a long way. And for me, law is supreme and no one is above the law. Many narratives have come to me that you should not have demolished. Our own batchmates. No, you should not have demolished. It's a waste of money. There are millions of people who can keep that. There are not many people who can follow the Supreme Court. But I looked at it that way. Law is supreme. The Resident Welfare Association won the legal battle after 12 long years and 30 hearings. This is the biggest win. And some of them are not alive today to rejoice. The event has sent shockwaves amongst the real estate industry. People will now think twice. Buyers like you must ask question when you buy an apartment. Your life saying you're going to buy. Question, take an undertaking. If in future, Maradu came after 10 years of people occupancy. Public has gained more respect for the law. And I am saying public needs to be careful when they invest on real estate. Finally, I take pride in saying civil engineers have come to resurrect the law. All these years we are cursed. Look at the bad roads, look at this, look at that. But for once, as a civil engineer, I feel proud that we have been called to resurrect the law. Now implosion is an option in India. Almost every week I get some inquiry or the other, but we have to be choosy. So as a professional, for me it's a job to be done. You can't tell an executioner who is executing somebody due to an order by the law that he is a killer. No, he is doing a job. And I feel never should such demolitions come in India. Somebody broke the law, somebody's got hurt, and somebody has to, it should not happen. Never should such industrial demolitions, yes, we are doing for upgradation of the industry. Then efforts of thousands of engineers and workmen had to be demolished in 9 seconds, very sadly. So if you say these are the lessons learned to go forward. And I need to acknowledge all these people who helped us get the job done, and you can read the list. It's not a one person or one man effort. It's so many of them contributed in so many ways. It's a video capsule. I exceeded my time. I'm not playing the video again. This is a video capsule of the whole event from start to beginning. I'll skip that also. So this is before and this is after. The towers are gone in 9 seconds. Thank you very much.
Thanks a lot, and we will be having an interactive session. We are running really short on time, and I would like to request that we will be having space for 2 questions.
You can use this mic.
Good evening, sir. That was an excellent presentation.
Please introduce yourself so that others may know you.
My name is Francis George. I'm in the managing committee of Thrissur Management Association. I'm also a member of AEA. 2 questions I have. One is, how is PPV measured, the peak particle velocity?
Yeah.
What's the mechanism for that? The second question is, you mentioned weakening of the structure prior to the blast. How was that done? Was that using only chipping, or was a mini explosion done for that?
Okay. Peak particle velocity is measured by instruments like this. What you see here is called a geophone. It costs about 4 lakhs. We put 2 because one gets redundant and some of them get damaged because debris may come and hit at at speed. So this is a, it has got, and I've explained here, one is an accelerometer, and from the accelerometer we calculate, double integrate and get the velocity and the displacement. So this is all built in this. So that answers your first question. It is a readily available instrument. Today it's available as a wireless, and this can be placed and you can record it. You can take it away after the blast and download it in your laptop and analyze it, and you have to process it. When it's processed, you get graphs like this. Your second question was, how was it weakened by simple chipping? No, one slide had that method. So the weakening was done only by hand chipping and by using breakers with mini excavators. Thank you.
Hello, I am Raghu Raman and of TMA. My one question is, how much is the cost involved for this demolition? Could
No, I don't know. Commercially, I am not answering.
Okay.
You can say cost involved to whom? To the builder?
Builder.
He has given an interview on the same night in India Today. So you can watch that. He's put some numbers. I normally avoid giving numbers. I may be wrong.
Good evening, sir. My name is Sachin Aravind. I am a project manager to the. I was wondering what happens to the foundation. Was it demolished or kept intact?
So good question. So I didn't talk about it. This building had 2 basements. Our blasting, if you see the drawing, our blasting was not to the second basement. Our blasting stopped with the first basement, and the lower basement was filled with the debris. I said no, 100 truckloads of side walls and partitions and floorings. It was filled. Why it was filled was, the builder said, we may want to reuse the foundation. The raft will be removed and the piles will be reused. So the foundation we didn't want to be disturbed. So we had filled up that 3 meters of fill right through in the basement. We had the debris, and the fall was on the debris. So that answers your question.
My name is Vijay Kumar. I am a managing committee member of TMA. I am not an engineer. So it's regarding this ethical issue involved. You are also telling before that many of your friends had asked you why go for a demolition instead of that, make use of that building for some other social purpose. I also feel the same way. For example, in Noida, at that point of time, that was an illegal construction. And it was an illegal construction. And now people say that if they apply for construction again, it will be granted because the law has been changed. See, it ultimately depends on the view taken by one particular individual or at least 2 individuals. Of course, they are the judges of the Supreme Court. But how much of destructive activities are taking place here? It is totally a negative thing, and actually people should come forward and object to these types of demolition. In fact, in Kerala, in Manade, most of the politicians said that your building will never be demolished. We are with you, we are with you. And ultimately, there is contempt of court and other things. I think that people should come forward against this. And one thing is, people say about corruption and all. No correct official is being booked. But most of the people who have given the sanction, they are no more there in the service, they would have retired and no action can be taken. So ultimately, it is to satisfy the ego of some of the, I would name the person that these types of decisions are not done. I as a person, I am a retired Chief Commissioner of Income Tax as a civil servant, strongly object to demolition. If it is illegal, levy some fine or make use of that, let the government take over and make use of that for some other purpose. I want your take on this.
In the initial itself I said, in the lessons learned, if you see, never should demolitions be necessary. That's because we have a gun, you cannot shoot anybody. So I agree with you fully. But when all the arguments went on for after 9 years, it had to be done. All that they would have considered all that. And a lot of narratives. It's let's say 200 crores was lost by the builder. But he's 20,000 crores worth. For him, it will not even hurt him. He will keep violating. So where do we stop? So we can keep debating. But for me, it is an engineering job to be done. I agree with you. That's why I put this. Never should such demolitions be necessary in the future. Which means we have to go by the law. And gullible buyers are getting caught. In Maradu, one of my professors on IIT, Dr. Matthews, he almost committed suicide because his lifetime earnings, he called me and said, Mohan, I'm in the streets. Professor Matthews, in fact I invited him here, he's not well. So there is a movie also taken because of this, showing the sorrow of this. But what do? We don't make the law. We can only talk from the ground, shout from the ground.
So can I ask a small question, a very small question?
Yes.
This building with this 35 stairs wide height, the builder definitely must have made a puja before the construction started.
I don't know.
He made a definitely done a puja. And at the time of demolition also, you have done a puja. Either of the pujas have failed. What has happened to the puja? One puja has failed, the other puja has become.
No, he could build safely 33 stories. For me, the job is
your puja has become very successful. Your puja has become very successful. The puja of the person who constructed it became futile.
Sir, I have a doubt. I am basically a mechanical engineer, TMA life member. My doubt is actually the explosion, the delay, all those things are set because of by the support of some electric circuits, some external power supply. Whether the first explosion may affect the settings in the later stage, how you can ensure it?
So that's a very detailed question. First of all, we are not using any electrical detonators here. See, that's why it's a fail-safe system. The last mile, if you see the activities on the day, the last mile, about 100 meters, something like that, was the final electrical cord with the dynamo to generate the electricity to take the first blast. The rest of the things have no electrical energy at all. We use what is called as the shock tubes and emulsions. Very safe method. So earlier days, you are right, we had electrical delay detonators which I used earlier. Now we have these better explosives. So very safe. So only the last mile, we have a manual dynamo to create the capacitor to create the current and press it. That charge will go. Only that stretch is electrified. That's when we have a lightning or we have some short circuit, it can happen. Rest of the whole building, we have about 7-8 kilometers of wire. What you saw yellow color? No. It's a different method we use.
So we'll be having one more question. Yeah. My name is Ridish, I am a member of the association. My question is that what is the software that you are using for simulation? And the second one is regarding the accuracy. Like you have made a lot of assumptions in terms of the modulus or the strength and other things. And you could blast it near to perfection. So how is this possible?
So we do a software, it's called collapse analysis. It's a custom software. There are very few companies who do it as a job. There is a company which I used in Germany for first I showed 3 buildings. This building, Olivakam, which was a building which collapsed due to structural failure, and the second mirror image building was there, and that was a case where there are companies who have built their own software for collapse analysis. Our IITs and all do not have this software. Jet Demolition have their own software, and this gives you various scenarios. When we choose the column, to which are the columns and which are the floor to make zero capacity, we use that analysis. We also do the 3D modeling and then design the fall, putting gravity as a force. So it's complicated, but it's a proprietary software. It's not an open domain. Second question?
Regarding the assumptions like modulus and other strength and other factors.
No, all the data from the site we got. We did the coring in NDT test and got some basic data, and we had the reinforcement drawings with us. With that we could do, but still the test blast was a learning for us.
So that's the end of that interactive session.